Okay, welcome back to Unit 3. We are continuing to look at air pressure. So of course, just to recap, air pressure is mainly dependent on the weight of the atmosphere in a specific location. So if you look, for example, in this scenario, we have someone on a steep area versus someone on a flat area. And of course, if you're on any form of low elevation, you know that the air around you is going to be very heavy. And so that is going to bring a higher air pressure in that area versus if you're on a steep terrain, you know that the atmosphere is going to be thinner, so of course it's going to be of a low pressure that whoever is there is going to be experiencing. So of course air pressure changes daily, and the more dense the air is, the more pressure it will exert. And usually air pressure is measured from sea level, and the averaged one is roughly around 1013 millibars. Anything below that is going to be considered low pressure. So that is a hint for you to understand a low pressure versus a high pressure system. So with a high pressure system, it has a dense air mass, and it's usually cooler and drier than the surrounding air, versus a low pressure system, which is a lensless air mass that's usually wetter and warmer than the surrounding air. So now we're going to jump to the factors that influence air pressure. First one, altitude. Of course, you know altitude has to do with how steep or flat an area is. So simple equation, higher elevation equals less pressure. Lower elevation equals high pressure. So as pressure decreases with altitude, at higher elevations or altitude, there is a smaller column of air, so it's thinner, and so this will exert pressure on the surface compared to that obtained at lower elevations, right? So if we go, for example, to the beach, the air pressure is going to be heavier because, of course, it's a flat area, versus if we go to Blue Mountains, the air mass is going to be thinner. So, of course, we're going to experience a lower pressure system there. Temperature is another factor, and of course temperature will have an inverse relationship with pressure. So just to understand this, when the air gets warm, it tends to spread out and it actually rises, so there's less air pressing down, accounting for low pressure air system, right? But when the air cools, in this case, it's going to be heavier and it sinks. So it's going to push more onto the surface, and so in that case, you're going to have a higher pressure system. So if we take, for example, the scenario with a balloon, once you blow air into the balloon, and with hot air, it's going to expand and it's going to rise, right? Versus if, for example, you're using cooler air, or you put that same balloon in a cooler surface or cold water, it's going to shrink. And that's the whole idea of expanding and contracting, which has to do with temperature differences. So of course, on a sunny day, the place is going to be warm, especially in the city, and so this is going to account for a lower pressure system. And so throughout the day, depending on the conditions, it can therefore bring some rain or some form of unstable condition because of how warm the area is, right? Moisture is another factor that influences air pressure. So moist air is usually less dense than dry air and therefore exerts less pressure. And this is because, first of all, moist air is usually associated with warm air. The water vapor may remove nitrogen and oxygen, which are important gases, or the most abundant set of gases in the atmosphere. And so when this happens now, it reduces the amount of air molecules, and this in return helps to create humid or moist air to exert less pressure.